Okay, in this video we're going to go through how you do the fitting of a curve to some data for example 2 when we're looking at derivatives of exponential functions. So I put a link in there to the instructions that I'm going to be following. So I'm just going through these just step by step using that data. This is kind of assuming that you've already taken those, put the function into a wind plot, use the tangent slider to get the slope of the tangent at each of those points. So our instructions are go to Desmos.com. All right, Desmos.com/calculator, start graphing, and here we are. So in the upper left it says choose add item. Instead of choosing add item, I'm just going to click on this plus symbol here, which adds an item, and we're going to choose table. And then we're going to type our data into this table here. So the data that we have, let's see, our x values went from -3 up to 5. And then I'm just going to put in the y values. Now remember, the y values represented the slope of the tangent that you found from wind plot at each of these x values. And I'm just going to put them into 4 decimal places here. 3466, 0.6931, 1.33863, 2.7726, 5.54, 52, 0, 04, 22.1807. And you notice that as I put in each x and y, it adds a little green dot onto our plot over here to show you what is being graphed. Okay, so we've got our data in, we've got our graph set up here. It says step 4 says click on the wrench in the upper right to change your graph settings. So if I click on this wrench here, I can change the range in the x-axis and the y-axis. I'm just going to change the y-axis range. I'm going to make this go up to 25. That gets all of our data points in here on the graph. Our largest one was 22.1. And I think our x-axis is probably okay. All right, modify your x and y value. Oh, step 5 is just telling us how to modify that. So step 6, decide what type of equation the data represents. So they give us this hint. Like if I just click in this area here, I should be able to add something here, an expression. Oh, let's add it down below here. They say that we should use an expression of the form y equals k times, so that's the star symbol for times, 2 to the exponent, and to get the exponent I do the little circumflex, the shift 6, to the exponent x. Now it gives us the option here of adding a slider for k. So we just click on that, and there's our slider for k. And by moving this slider back and forth, we change that value of k till we get something that is going to match up with these data points really nicely. So that looks like k is 0.7. Now step 8, adjust the values of the sliders. So if I want to get a little bit more accuracy, I know it's somewhere around 0.7. I could narrow this down to, I could set the range of the k value here to be something like 0. Let's say 67 up to 0.73, and I can go in steps of let's do 2 steps of 0.01. So we're still at that midpoint of that range, still 0.7, but if I move this slider one way or the other, I should be able to get this thing to fit a little bit better. 9, 6, 8. Let's make the step size even smaller. There we go. And now most of these I don't even see anything. What I'm really focusing in on is this dot right at this last data point up there. I want to get this so that that red line goes like right through the center. Okay, and that's going to be probably as good as it gets, right about there, maybe there. Okay, so my equation is going to be y equals 0.693, that's my value of k, times 2 to the exponent x. Then the last step in that link that's been provided is showing you how to get an r squared value, which measures how close it is. That's really not necessary for what we're doing. As long as you can get a graph that is pretty close, I think you can work your way through the rest of this activity pretty easy.